welcome to week 10 of BUSA 207 Business Statistics for Decision Making. This week we're going to start taking the information that we've learned and used about probability distributions and applying them to real world situations. One of the problems that you had to do dealt with sampling of products that are testing is destructive. So you can't test all of them, and so we just decide to test using a sample. So why do they do that? Well, there's a lot of reasons. One reason we've seen already is if it's destructive sampling, you can't test everything. Another reason we do sampling is because it's cheaper. Less time, less energy involved in sampling a few of population than it takes to go through and take a census and count everybody or test everything in the population. So that's another reason we use sampling. A third reason we use sampling is we can get very, very good results from sampling. Based on statistical information, we can be very confident in our answers based on samples. So that's why we'll do sampling. When we do sampling, we need to understand some things, though, because almost every time we take a sample, the statistic we get, the characteristic of the sample, will not be exactly the characteristic of the population. It'll be a little off. I guess there's situations it could come out exactly, but typically it doesn't. So we call that sampling error. And one of the things we need to do is learn to deal with sampling error. It exists, and we know how to deal with it using statistics. So in this chapter, we'll talk about sampling error and how we deal with sampling error. One of the ways that we look at sampling error is we take all of the possible samples of a population of a basic size. In the slides, they talk about a sample, I believe, of 7 people, and you wanted a sample, a population of 7 people, and you wanted a sample of size 2. Well, there were 21 different ways you could do that. Well, that's a fairly simple problem. If you assume a population of, say, 2,000 and you want a sample of 20, how many of those samples could there possibly be? Well, an awful lot of them. But how many doesn't matter, because the central limit theorem helps us understand what that sampling distribution looks like. If you take, for instance, the mean of the samples, of all possible samples of a certain sample size, the central limit theorem tells us that as the sample size gets larger, that sampling distribution becomes normal. And based on that, we can use the normal distribution for the sampling distribution of samples to look at our population. Then we say, well, we have our sampling distribution. What's the standard deviation of that? And again, the central limit theorem tells us that. It's called the standard error of the mean, and it's the standard deviation of the population divided by the square root of the sample size. And one of the most common mistakes people make is not taking the square, or dividing by the square root of the sample size. And they just use the population standard deviation, and that gives you an error. So make sure that when you're working with a sampling distribution, that your standard deviation, which we call the standard error, is the standard deviation of the population divided by the square root of the sample size. Then we use those sampling distributions in the real world to come up with conclusions about our population. For instance, we can set up a confidence interval around a number and say we are 95% confident the true mean of this population is in this interval. And we can make some real decisions based on that. So that's where we're going with this chapter and in week 10. And I hope you're enjoying the course, and I'll have another introduction for you next week. Thank you.